Greetings, class. Mr. Munir here with your Module 15 test review. I hope you have been enjoying your life and are ready for some math to be imported into your brain through the watching of this video. So here's the deal. What I'm going to be going through is ready to go on and assessment readiness for Module 15. So that's page 465 in your book if you want to follow along in your book and maybe pause. And I definitely recommend that if you're watching this review video, like before I do the problem for you, just pause the video and see if you can do it for yourself. So with that being said, let's get started right away. 15.1, this is the first problem I'm going to do. So if you want to pause the video, pause it now, and then pick it back up when you've got your answer. Let's take a look. 15.1, two-way frequency tables. Martin collected data from students about whether they played a musical instrument. The table shows his results. Use the table for exercise 1 through 4. Of the students surveyed, how many played an instrument? Okay, well, I'm going to go ahead and just fill in this last value because it's pretty easy to get. 88 minus 48 is 40. Okay, of the students surveyed, how many played an instrument? Well, that's this total here. So 200 total students surveyed. 112 were boys, 88 were girls, 90 played an instrument, and 110 did not play an instrument. So that's 90. How many girls surveyed did not play an instrument? So girls, no instrument, that's 40. So when we just filled in. What is the relative frequency of a student playing an instrument? Okay. What is the relative frequency of a student playing an instrument? What does that mean? It means what's the percentage of all the students, that's 900 or 200 students in total, what's the relative frequency that they played an instrument? So that would be 90 over 200. So the total number of students that played an instrument over the total, 90 over 200 is 0.45. Or in other words, that would be 45%. Okay. What is the relative frequency of a boy playing an instrument? So a boy playing instrument, that's that total right here, 42. So now we're doing 42 over 200. Okay, and just to be clear, this is not conditional relative frequency. They're not saying what's the frequency of someone playing an instrument given that they're a boy. If that's the way they worded it, that would be conditional frequency, and that would be 42 over 112. But they're just saying what's the relative frequency of a boy playing an instrument, so that's 42 over 200. 42 out of 200 is 0.21. 0.21 or 21%. That's it. Cool. Let's move forward. 15.2. All right. Two-way relative frequency tables. Students were asked how they traveled to school. The two-way relative frequency table shows the result. Use the table for exercise 5 through 7. Write answers as decimals rounded to the nearest hundredth. What is the joint relative frequency of high school students who ride the bus? Joint means the intersection between two, right? So the joint relative frequency of high school students who ride the bus, that's 0.112. Pretty straightforward. What's the marginal relative frequencies of students surveyed who are in middle school? So marginal means out on the margins here, right? So that would be 0.42. What is the conditional relative frequency that a student rides the bus given that the student is in middle school? So bam, conditional relative frequency. That means we're not going to be dividing over the grand total. We're going to be dividing over the students in middle school. So we're interested those that ride the bus that are in middle school. So here's middle school. So 14% of the total are middle schoolers that ride the bus, but there are 42% middle schoolers in total. So I just take this number 0.14 and divide it by 0.42. So 0.14 divided by 0.42 is 33.3%, or 0.33 repeating. I could just say 0.3 repeating would be the correct way to do it, or 33.3 repeating percent. Okay, so I don't want to just blast this past you, because usually what we're used to is getting conditional relative frequency when we have just a frequency table. But we have a relative frequency table which shows us the percentages or the relative frequencies. So the question is, how can we still treat it in the same way? Well, as a frequency table. Well, let me just back up for a second. If this was a frequency table, this would just be numbers, like, oh, 14 students rode the bus in a middle school, and there were 42 middle schoolers in total, and 100 students in total surveyed. So it would just be numbers of actual students. But here we don't have those numbers. We have the relative frequency, which is the number in each of these boxes relative to the total number of students surveyed. So that's why you have 0.14, 0.1, 0.42 instead of whole numbers, because this is a relative frequency table. But in finding the conditional relative frequency, I can treat it the same way. And the question is why? Well, think about it like this. If, let's say, there were 100 students surveyed, well, then I just multiply everything by 100. It would be 18 middle schoolers rode the bus, 8 did other in high school, 38 rode a car. I'm sorry, 18 middle schoolers rode a car, 38 high schoolers rode in a car. There were 26 bus riders in total, 58 high schoolers in total. So if there were 100 students, then everything would just be multiplied by 100. And the most important thing is everything would be multiplied by the same number. So if there were 100 students and I found the conditional relative frequency of people that rode the bus, students that ride the bus, given that they're a middle schooler, then it would just be 14 over 42, which effectively is the same thing as doing 0.14 over 0.42. So to be very clear, this table will have the same proportions of this over this as just a regular frequency table that has whole numbers. And the reason why is because no matter how many of these students there are in total, let's say instead of 100 students, there were like 573 students in total, right? Well, then this box would be the relative frequency 0.14 or 14% of 573, right? And this box would be 0.42 of 573. And then when I wanted to find the conditional relative frequency, I'd do this divided by this, which would be the same thing as 0.4, this number divided by this number. And as you can see, this would cancel out, and you'd just be left with 0.14 over 0.42, which is the same thing. So I didn't want to just make it seem like it was mathemagic, like, wait, can you do that? Yes, you can do it, and this is the mathematical proof that you can, because no matter what the total number of students is, it's going to cancel out, and the proportion for that conditional relative frequency will be the same for a relative frequency table as it would be for a regular frequency table. Okay, I hope that clicked. Love you guys. Let's move on. How can you use two-way tables to solve real-world problems? I mean, it's just, there's so many. It's just, this is a wonderful way of presenting data that can lead to things being easily analyzed. And when you can analyze data easily, you can draw conclusions easily. You know, if I gave you a book with a bunch of facts in it, and the facts were scattered throughout the book and all over the place, and some of them were related and some of them weren't, and they weren't really organized at all, it'd be hard to draw conclusions about the facts in that book. But when I present that data to you in a concise and a very clear way, and well organized way, then it's easy to draw conclusions from that data, and drawing those conclusions helps you to, you know, take action. If you have wisdom about something based on drawing conclusions from data, then you can take wise action. Okay, um, let's continue. Module 15, assessment readiness. All right, the table gives data on the length of time that teachers at 10th Avenue High School have taught. Use the table for exercise 1 through 5. How many female teachers have taught for fewer than 10 years? So fewer than 10 years, female teachers, 25 minus 4 is 21. Boom, C. What is the relative frequency of teachers who have taught for 10 or more years? excuse me, let me just go ahead and bring this in. Okay. So this one was C. Relative frequency of teachers who have taught for 10 or more years. So it doesn't matter if they're male or female. This is going to be just 10 over 40, which is 1/4, or just 0.25 or 25%. What is the relative frequency of male teachers who have taught for fewer than 10 years? So male teachers, fewer than 10 years, that's them. 9 over 40. Okay, math. You know it's not 0.6. You know it's not 1.5. You know it's not 0.09 because that would be 9 over 100. So that's the only reasonable guess. And if I did that division, I'd find out that that was the case. Yeah, right? 9 divided by 40. Awesome. Cool. Test taking skills. You don't always have to know the answer. You just have to be able to figure out what the best possible answer is, or if it's the only possible answer, as in the case that we just saw. Number 4, what is the joint relative frequency of female teachers who have taught for more than 10 years? Okay, joint relative frequency means intersection. Joint relative frequency of female teachers who have taught for more than 10 years. So technically this should say for 10 years or more because that's what this says, but we'll let them slide. So that's this one here. That would be 4 over 40. 4 over 40 is dun, 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 dun. 4 divided by 40 is 0.1. Oh, 10%, obviously. Okay. What's the marginal relative frequency of teachers who are female? So margins, that's out in the margins here or here. Joint is in this inner box. Margins is out in the margins. Okay, and this is obviously the grand total. Marginal relative frequency of teachers who are female, that's 25 over 40. That's more than 50%, so this is the only reasonable answer. And if I do the division, I'd find out that was the case, right? 25 over 40 is 0.625. Awesome. All right. Moving on. I'm not going to test you on this stuff right here. I'm not spiraling back. This is distance learning. We're staying focused. Okay, so let's continue. So don't worry about those questions. I'm skipping them. That means don't worry about them. All right, number 8. The table gives data on books read by members of the summer reading club. Okay, so we have boys and girls, fewer than 25 books, 25 or more books in total. And it's generally speaking, when you see a two-way frequency table, it's good to just take a look at it and just observe it, just like you would a graph or a histogram or any kind of chart. It's good to take a look at it and read it for what it is and be able to analyze it and figure out, okay, what is this two-way table showing me? Because if I go straight to the questions, then I'm gonna have to go back and look at it anyway, and then reread the question. So it makes sense to analyze your chart or your two-way table, take a look at it, see what it's telling you, and then go ahead and read the questions. So we did that. Now let's go ahead. Find the relative frequency of a club member reading fewer than 25 books. So relative frequency, a club member, doesn't say boy or girl, fewer than 25 books. So that's 16 out of 64. 16 out of 64 simplifies to 1/4, which is 0.25 or 25%. And on the test, you can say 0.25 or 25%. It's totally cool. But if you do say percent, make sure you put that percent symbol behind it, okay? Make sure your decimal place is in the right place. Don't lose points for misplaced decimal points. Just don't do that. Okay. All right. Find the relative frequency of a girl club member reading fewer than 25 books. So a girl fewer than 25 is 9 out of 64. So I don't know what that simplifies to immediately. So it's not multiple choice. So let's go ahead and do the division. 9 over 64 is 0.14. Awesome. 0.14 or 14% approximately. This is approximate. It's not an exact answer. And it's nice when it's approximate answer to do that squiggly equal sign, because that means approximately. Is there an association between being a girl and reading fewer than 25 books? Okay, so this is talking about conditional relative frequency, CRF. Conditional relative frequency is how we determine if there's an association. So we're talking about girls versus boys and reading fewer than 25 books. So what we have to figure out is the conditional relative frequency of girls as a proportion of the total number of girls, and boys that read the fewer than 25 books as a proportion of the total number of boys. So that would be 7 over 28, which simplifies to 1/4, which is 0.25. So the conditional relative frequency of boys reading fewer than 25 books is 0.25. What that means is, given that the student is a boy, there is a 25% chance that the boy has read fewer than 25 books. Okay, so now let's analyze for the girls. It's 9 over 36, which lo and behold simplifies to 1/4, which is 0.25, which again means, given that the student is a girl, there's a 25% chance that they've read fewer than 25 books. Awesome. So as we see, these conditional relative frequencies are the same. Therefore, there's no association. What that means, no association is another way of saying equally likely. That means it doesn't matter. Choose a boy or a girl. You're going to have an equal percentage that have read fewer than 25 books. Whereas if this came out as 0.5 and this came out as 0.25, you'd say, oh, there is an association. And the association is that if you're a girl, you're less likely to have read fewer than 25 books. But in this case, they're the same likelihood of reading fewer than 25 books. So there is no association. Okay. No association, equally likely. Okay, if there's a difference in that conditional relative frequency, then you've got an association. And usually the best way to describe the association is just use common words. Think about it. Hey, if you're a girl, you're twice as likely to have read fewer than 25 books. Or if you're a boy, you're twice as likely to have read fewer than 25 books. Whichever one. I mean, don't think too hard about it. Just look at it and say, oh, this is more likely than the other thing. Cool. That's it. All right. So don't try to blow anybody away with vocabulary. I know you guys are smart. This is an opportunity for you just to think real clearly and write out your conclusion. Now, just a tidbit on that. One of the beauties of data science is taking complex data and generating very clear conclusions from it. So that is a point to talk about too. It's like, when you're talking about your conclusions, just make it as clear as you possibly can. Hey, girls are twice as likely to have read 25 or more books than boys. There's no question. It's obvious, right? Okay, if I have a girl student, it's 50% of the time they're going to have read more than 25 books, whereas for a boy it's only going to be 25% of the time. Okay, yeah, the girl's twice as likely that they've read 25 or more books. You don't have to make it complex. You don't have to overthink it. Just be as clear as you possibly can. So on the test, if I ask you if there's an association, I'm not just looking for yes. I'm looking for, is there an association, and what is that association? Yes, there's an association. Girls are more likely to do this, or boys are more likely to have done this, whatever it is. Okay, just make it clear, make it simple, and you're golden. All right, I think that's it. It totally is. So let's see, what time have I got? Okay, only 18 minutes. I'm gonna go ahead and, oh man, there's a lot to this. Well, that's just the unit test. Okay, so let's take a look. Let's take a look at some of these selected problems. Okay, so module 15. Okay, so this is a frequency table. They're just showing you how to make the relative frequency table, converting from decimals to percents. Okay, that's obvious. By the way, this is page 469. All right, use the table as an example to answer each question. What is the joint relative frequency of patrons who are adults attending the 8 p.m. showing? So we have adults, children in total. There's a 5 p.m. showing and an 8 p.m. showing in a movie theater, and we're seeing who attended which one. What's the joint relative frequency of patrons who are adults who attended the 8 p.m. showing? So I'm just going to go ahead and write this out. So for those of you that are visual, you'll just have it visually. Okay, so who attended the 8 p.m. showing? Adults that attended the 8 p.m. showing, that's 0.31. That's this one right here. Joint relative frequency. This is a relative frequency table. It's right there in front of you. Don't overthink it. It's not conditional relative frequency. It doesn't say conditional relative frequency given that. No, it just says joint relative frequency. That means just divide that intersection by the grand total. So 0.31. Next question, what is the marginal relative frequency of patrons who went to the 8 p.m. showing? So 8 p.m. showing, marginal means out in the margins. We're not talking about adults or children, we're talking about in total. So who went to the 8 p.m. showing? That's 0.51, 51%. Boom, right there. Again, decimal percent is fine with me. What's the conditional relative frequency that a patron is an adult? Now we're talking about conditional. A patron is an adult given that the patron attends the 8 p.m. showing. Okay, so they're an adult. Okay, let me bring this in actually. Whoa, my mouse is doing weird things. Okay, so they're an adult. You know what? Let me use that other table. Actually, it would be easier. Okay. So, conditional relative frequency, that's my big keyword here, conditional, and then given is another thing. So, given that the patron attends the 8 p.m. showing, so I know that the total is 8 p.m. showing, that's going to be my denominator, so I can write that immediately. And the patron is an adult, so that's my numerator. There you go. So, this is telling you what's the chances that if I know someone attended the 8 p.m. showing, what's the chances they're an adult? That's what the given thing means. Given that they attended the 8 p.m. showing. So I know that they attended the 8 p.m. showing. What are the chances that this random person is an adult? Okay, well, the chances that that random person is 39 out of 64. You have a 39 out of 64 chance that that person is an adult. That's what that conditional relative frequency means. Okay, so 39 out of 64 would be 0.609375 or approximately 0.61. There you go. It's really that simple. Okay, so be on the lookout for conditional relative frequency, and that's that. All right, cool. Let's move forward, and this will be the last thing that we do. Okay, let's bring this whole thing in. Awesome. Boom, 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 boom. All right, Kalila has developed two different varieties of tomatoes called Big Red and Sweet Summer, which she grows in her garden. When she harvests the tomatoes, she measures the diameters of each variety. The results are shown in the table. Okay, so Big Red, Sweet Summer. Diameters less than 2 inch, diameters more than 2 inch. Cool. Use the data to create a two-way frequency table. Easy enough. So the first bit is going to be the same in this joint frequency, right? And then the totals, total number of Big Red are the ones that are less than or equal to 2 and more than 2. So 36 plus 45 is what? 81 in total. 28 plus 39. So total number of Sweet Summer tomatoes is 67. Then I just add them up columns. 36 plus 28 is 64. 45 plus 39 is 84. 81 plus 67 is 148. And just make sure these add up. 64 plus 84 is 148. Cool. What's the relative frequency of a tomato having a diameter that is greater than 2 inches? Okay, so greater than 2 inches is 84. So it's going to be 84 over the grand total of 148. So remember, it's just relative frequency, not conditional relative frequency. So I just divide by the grand total. 84 divided by 148 is 0.57, 0.57. And for the record, you're totally going to be allowed to use a calculator on the test, just so you know. What is the relative frequency of a Big Red tomato having a diameter that is greater than 2 inches? Okay, so this is joint relative frequency because I'm talking Big Red tomato having a diameter that's greater than 2 inches. So I'm talking about this right here, right? It's two variables, Big Red and diameter is greater than 2, right? And I'm interested in the relative frequency. So round to the, it says round to the nearest percent. So I should have said 57% here because it's asking for percent. Okay, so here is now 45 out of 148. And that's going to be what? 45 out of 148 is 0.30. Or in other words, it's approximately, because I'm rounding here, approximately 30%. Cool. Finally, is there an association between Big Red tomatoes and diameters that are greater than 2 inches? So Big Red tomatoes and diameters that are greater than 2 inches. What does this mean? It means, is it more or less likely that big red tomatoes have a diameter greater than 2 inches than the sweet summer tomatoes? Okay, so what this means is I have to figure out, okay, if I know I have a big red, oh, I know I have a big red tomato. What are the chances that I got a big red tomato that's got a diameter of greater than 2 inches? Okay, what are the odds? So if I have a big red tomato, what are the odds that that tomato is has a diameter of greater than 2 inches? Well, it's simple. I just do 45 over 81. That's going to be the conditional relative frequency. So the chances that I've got a big red tomato that has got a diameter greater than 2 inches is just 45/81 because there's 81 in total and 45 of them have a diameter greater than 2 inches. So that's approximately 56%. Then I want to check sweet summer because I want to see, is it the same likelihood? Is it more likely? Is it less likely? So clearly there are 39 that have a diameter of greater than 2 inches and there are 67 in total. Okay, so I'd say 39 out of 67. And I see that 58% of sweet summer tomatoes have a diameter greater than 2 inches. And so what does this tell us? Well, a couple of things. First off, to be real with you, these numbers are so close that I would be willing to say that there is no association because it's not like you've got thousands of tomatoes here and you've been collecting this data for years and years and years. This is just a very limited set of data, only 148 tomatoes, which is very small if you think about a farmer in a garden. I mean, I guess it's just a regular garden. 148 tomatoes is a lot, but it's not a very big sample. So 56% and 58%, I would argue that there is really no association. And you could say that. You could say there is, you could say, in my opinion, or there seems to be no association because the difference in percentage of the conditional relative frequency for the big red and the sweet summer tomatoes having a diameter of greater than 2 inches, the difference in that percentage is small. And so you could say it seems to be no significant. You could say significant. That'd be your keyword right there. There is no significant association. Okay. But with that being said, if you want to just be super stickler about it and say, if this is the only data I've got, well, technically speaking, it says that yes, it is more likely, or I should say, to make it very clear, because it's asking specifically about big red tomatoes. So I should say, yes, big red tomatoes are less likely, right, to have a diameter greater than 2 inches less likely to have a diameter greater than 2 inches than sweet summer tomatoes, than are sweet summer tomatoes, than sweet summer tomatoes. The grammar is questionable in this sentence, sorry, but I think it's pretty clear. Big red tomatoes are less likely to have a diameter greater than 2 inches than sweet summer tomatoes. Actually, I think it's than are, that would be the correct grammar, than are sweet summer tomatoes, okay? Big red tomatoes are less likely than sweet summer tomatoes. That's probably the best way to put it. Okay, big red tomatoes are less likely than sweet summer tomatoes. So take this whole bit and put it here, right? Big red tomatoes are less likely than sweet summer tomatoes to have a diameter greater than 2 inches. Clarity of communication. You have created, you've drawn a conclusion based on your data, and there you go. If I was answering this question on a test, I would say, yes, big red tomatoes are less likely than sweet summer tomatoes to have a diameter than greater than 2 inches, but the difference is not significant. Okay, because you don't want someone to read this conclusion and be like, oh yeah, well, I'm definitely going to get sweet summer tomatoes because they're more likely to be bigger than big red tomatoes. It's like, sure, but you're talking about 58% to 56%. And so is that really a good reason to buy sweet summer tomatoes versus big red? What if big red tomatoes just taste way better than sweet summer tomatoes? I don't know. First off, this seems like the names are wrong because big red tomatoes should be bigger. But anyway, the point is that you wouldn't want to make your conclusion sound super strong here. So it would be good to put a clarifying statement in there, such as, but the difference is not significant. So this is real stuff. This is data science. This is what real people do all the time. And nowadays, more than ever before, this kind of thing is very, very important. So I hope you guys have paid attention. For all you know, this might be something that you will use on a regular basis in your career. And I can say that with a confidence for this subject in ways that are sometimes more challenging to say about other chapters in the past. So I hope you've paid attention. I hope you understand this. I hope you realize the significance of this kind of data science and how it impacts the world. With that being said, that's it for me. Until next time, enjoy mathematics.